All right, class is the last lesson of the year, so we're going to talk about infinite geometric series, which means that they go on forever and ever and ever. Let's look at what happens when the number of the term number gets smaller as you go. Okay, so for the series that's 1/2 to the n, which is 1/2 times 1/2 is 1/4, so the second term is 1/4, and so on and so forth. As it keeps going, you should notice that this value, the last value, will get closer and closer to 0 because it's getting smaller, which means, let's see what that does for the sum. Well, if we just take the sum of the first number, 1/2, you get 0.5. If you take the sum of the first two numbers, 0.5 plus 1/4, you get 0.75. If you take the sum of the first three numbers, you have the 0.75, which represent the first two, plus 1/8, and we get 0.875. If we take the sum of the first four, we have the 0.875, and then we have 1/16 added to that, so we have 0.9375. And finally, we have 0.9375 plus 1/32, which gives us 0.96875. And if you plot this, 1 is 0.5, 2 is 0.75, 3 is 0.875, 4 is 0.93, and then 5 is 0.96. You should see that it's approaching a sum, and it'll approach a sum of 1. It'll never get to 1, but it's approaching it. Remember, we called that an asymptote. So because of that, look at what happens with the formula. As this becomes very, very big, the value, as n becomes very, very big, the value goes to 0. Like the last term would be like 0. It's 1/1,000,000,000. It's not a big deal. So in the formula, this term goes to 0 because this is going to go really, really small. And so you get a new formula for these infinite series, which is just stating that it's the first term over 1 minus the ratio. Now, these only work, though, if the series is getting smaller each time. In order for it to get smaller, r needs to be, the absolute value of r needs to be less than 1. And if it is, we say the series converges. If the value of r is greater than 1, though, or the absolute value of it is, then it diverges, which means we cannot do the problem, because if it's diverging, it's not converging on one number, one sum. So here's what you have to do. You have to figure out what is the r value. Well, based on the way, first of all, you have to see that this is an infinite sum. You look and see what the r value is. The r value is 0.7, which means it converges, so we can do the problem. Then we find out what a is. Well, a1, I should say. Put a 1 in for k. 1 minus 1 is 0. 0.7 to the 0 is 1, so the first term is 3. So the infinite sum then is just 3 over 1 minus 0.7, and that turns into 10. So if we add up all the terms in this series for infinity, it's 10. If you look at 2 here, the numbers are getting bigger, which is bad, and that's because r is equal to 3. Since r is equal to 3 and it's bigger than 1, we say this diverges. And then we're done. We can't find the sum. Do not find the sum of that, because think about it. It's never approaching a number. It'll just go on forever. All right, this one, to go from 1 to -3/4, r is -3/4, which means that we can do this one. It converges. A is equal to 1 because it's given. So the sum of the infinite amount of terms of a geometric series is 1/1 minus -3/4, which is 7/4. So when you flip 7/4 over, you get 4/7. Okay. Again, we knew that was going on for infinity because of the dot, dot, dots. This is going on to infinity because it's infinite. R here is equal to -1/2, so it converges. The first term, if you put a sub 1 in, or you put 1 in for k, you get actually 1, right? It's -1/2 to the first power, or 0 power, which is 1. So we have the sum of the infinitely many terms of the infinite series. We get 1/1 minus negative 1/2, which is 2/3. Okay. This one here, you look at r. R is equal to 5 over 4, because that's what you're multiplying by each time. That's bigger than 1. This diverges. If you're not sure, write out a couple terms and notice if they're getting bigger, you can't do it. If they're getting smaller, you're good. And then finally, this one here, it looks like it's just multiplying by 1/4. Again, to figure that out, you can do 3/4 divided by 3, or 3/16 divided by 3/4. So that means this converges. The first term is 3. So the sum of the infinite many terms, and we know it's infinite because of that, is 3 over 1 minus 1/4. And that's going to give us 4. So that's it. So you have to just identify if it converges or diverges. And if it converges, use the more simplified formula to figure out what the sum approaches as you go to infinity. All right. And that is it for the year. Congratulations.